Hello students, welcome to my channels. Today we discuss on the chapter Hydrosphere. What is hydrosphere? About 70% of the surface of the earth is covered by water and the remaining 30% by land. All water bodies like oceans, seas, lakes and rivers of the earth surface together form the hydrosphere. The large water bodies are known as ocean, such as the Pacific Ocean, Atlantic Ocean, the Indian Ocean, the Arctic Ocean, and the Antarctic Ocean. Let's start the chapter. What is ocean current? Ocean current are regular movement of water from one part of the ocean to another. They may be temporary or long lasting. It moves horizontally. What is drift? A very slow moving ocean current with an average speed of 3 to 4 km per hour is often called drift. The ocean current are two types: warm current and cold current. Warm current has some characteristic. Number one, they flow from tropical areas to the polar region. They are warm and light. They flow along the surface of the ocean. And the characteristics of cold current is they flow from cold polar region to warm tropical regions. They are cold and heavy. They flow along the lower level of the ocean as undercurrent. Causes of origin of ocean currents. The main causes of ocean currents are rotation of the earth, prevailing winds, temperature and salinity of ocean water, centrifugal force, shape of coast, seasonal variation, and density of ocean water. And another point is melting of ice. Now, rotation of the earth. The rotation of the earth generates a centrifugal force which causes generation of current in the ocean water. It moves in a clockwise in the horizontal hemisphere and anti-clockwise in the southern hemisphere. Now point number 2, prevailing winds. The planetary winds or prevailing winds push the surface layer of the ocean current in front of them in a constant flow. These winds move freely over the vast ocean surface and drag the surface water to the direction in which they blow. Number 3, temperature and salinity of ocean water. Temperature is low at the pole and high at the equator. The polar water is cool and become heavy and sink. The equatorial water is warm, light and floats. This creates a convectional current and the polar water moves towards the equator and vice versa. Water of high salinity are dense and heavier. They sink and flow below the less saline water. While the water of low salinity are lighter, they rise up and flow along the surface. These ocean currents are caused. Thus, ocean current are caused. These are known as the thermohaline circulation. They are called the thermohaline circulation. Next point, centrifugal force. The centrifugal force of the earth is greater at the equator than the poles. Hence, water current moves from equatorial region to the poles. Shape of coast. The shape and direction of the coast of the land masses also change the direction of the current. Next, seasonal variation. Seasonal variation causing movements of ocean current in most pronounced in Indian Ocean. The current in North India Ocean change their direction from sea season to season in response to the seasonal rhythms of monsoon. In winter, the northeast monsoon drives the water along the coast of the Bay of Bengal to circulate in an anti-clockwise direction. A similar anti-clockwise circulation develop along the coast of Arabian Sea also. In summer, a strong southeast monsoon causes clockwise circulation of water in the northern Indian Ocean. Melting of ice. Melting of ice raises the sea level and reduce salinity, influencing the ocean current. Number 8. Density of ocean water. Difference in density control the flow of density current. Density of ocean water depends on temperature and salinity of the water. The density of water decreases if temperature increases and vice versa. The water which is more saline is denser than water with less salt content. The colder and denser polar current therefore sink and flow towards the equator, while warmer and less dense of tropical waters move as surface current towards the pole. Now, effects of ocean current. The various effects of ocean currents are: number 1, difference in temperature, rainfalls, formation of banks and its commercial importance, parity in temperature, fog and storm, frost-free harbor navigation and occurrence of desert. First, difference in temperature. The region where warm ocean currents pass become comparatively warmer, while the region where cold ocean current pass become comparatively cooler. Now, rainfall. Wind crossing warm ocean current gather enough moisture and cause much rainfall, but wind causing cold current do not gather much moisture, hence do not cause much rainfall. El Nino also bring much amount of rain and lowering the temperature. Number 3, formation of bank and its commercial importance. When warm and cold current meets, the iceberg carried by cold current melt. The sand, pebbles, large amount of stone, etc. being carried by the iceberg get deposited at the base, creating sandbank. These are economically useful as low depth of the sea. In this region, attract much fish which can be easily acquired. Next, parity of temperature. The ocean current helps to balance the distribution of heat of the water between higher and lower latitude. Hence, they influence distribution of world temperature. Fog and storm. Region where warm and cold current meet remain foggy almost throughout the year and often face storm. Frost-free harbor. Warm current helps to keep the mouth of the harbor of higher latitude frost-free even in winter. Navigation. Ship can move faster and easily along the ocean current. Movement against the direction of the current is difficult, time consuming and fuel consuming. Occurrence of desert. Cold water current cool the air above it and present a cool, dry weather in the coastal areas of the west of the continents. As an example, Atacama, Kalahari are the desert which lies there. Next, what is tide? Tide are periodic rise and fall in the level of the ocean and seas caused by the attraction of the moon and sun, rotation of the earth. The tide are two types, the high tides and low tides. The tide in which the level of the water of the ocean rises up higher than the solid crust of the earth is known as high tide. And what is low tide? The tide which is in which the level of the water of the ocean fall is known as low tide. These two types of tide occurs by the attraction of earth by the sun and the moon. Primary tides or direct tides and secondary tides and indirect tides are occur due to the rotation of the earth. The tide produced on the surface of the earth facing of the moon are called primary tide or direct tides. At the same time, there is a peeling of ocean water on the antipode or the opposite side of the earth. These tides are called secondary or indirect tides. High tides and low tides each occur twice a day. Why? Each and every part of the earth face the moon after every 24 hours. The side that faces the moon experience direct or primary high tide and the opposite side experience indirect or secondary high tides. Again, as the earth rotates, the place which experienced primary high tide will now experience secondary high tide and vice versa. This place lying at the right angle of place experiencing high tides will experience low tide. Hence, two low tides occur in each place. Thus, we see that both high tide and low tide occurs twice a day. These they occur at an interval of 12 hours and 16 minutes. Calculation between the difference in high tide water and low tide water. The moon rotates west to east and complete on rotation in 28 days approximately, and it rotates in the same direction as the earth rotates. If the moon had been stationary, each place of the earth's surface would have come exactly under if after 24 hours, but moon revolves and takes 28 days. So, in a day, the moon moves further 13 degree, 360 degree divided 28, which is equal to 12.8 as approximately 12.8 degree, approximately 13 degree on its way. Therefore, it takes an extra time of about 52 minutes. 13 degree into 4 is equal to 52 minutes to each place. So, the interval between two corresponding high tides 24 hours 52 minutes and the time of high tide of a particular place also change. Thus, the interval between high tides and low tides is about 24 hours 52 minutes divided by 2. That means 12 hours 26 minutes. The ebb tide occur nearly 12 hours 26 minutes divided by 2 means 6 hours 13 minutes after the high tide. So, in 24 hours there is a to high tide and low tide occurs in a place. Now discuss the causes of tides. The main causes of tides are gravitational pull of the moon. Although both the sun and the moon exert gravitational force on the earth, the sun's force is only 46% of that of the moon due to its large distance from the earth compared to the moon. Hence, the moon's influence on the tide is twice as strong as that of the sun. The water of the earth nearest to the moon is pulled by its gravitational force. This makes the water on this side bulk, causing high tide. Water on the opposite side also experience high tide. At the comparatively lower scale, the area perpendicular to these areas experience ebb or low tide. Point number 2, effects of centrifugal force or rotation of the earth. Rotation of the earth causes generation of centrifugal force which tends to throw the water outwards. This causes the rise of water as tide. Now what is spring tide? The highest high tide are known as spring tide. The sun and the moon combines pull is effect on the earth. This result in highest high tides. On a full moon day, the earth lies in the between the sun and moon. The attraction of the sun and the moon at a place and its antipodes causes very high tide also. This is the picture of full moon, spring tide, and new moon. What is CGG? When the sun, the moon and the earth come along the same straight line, the fact is known as CGG. And in astrology, two types of position are found in CGG: conjunction and opposition. Conjunction at the time of full moon, when the earth comes between the moon and the sun in a straight line, the position is called conjunction. Opposition at the time of new moon, when the moon comes between the earth and the sun in the same line, this position is called a opposition. This is the picture in springtide or full moon, earth between moon and sun. This is a conjunction CGG. And in a new moon time, sun, moon and earth in a same line. This is a opposition CGG. This is called opposition CGG. Neap tide. The lowest high tide are known as neap tide. They occur at the first and third quarter of the moon. On this day, the sun and the moon are at right angles to each other in a relation to the earth. The gravitational pull of the sun opposes that of the moon. Hence, weak high tide are produced. This is the picture. Sun and moon, listen. right angle. Next, apogee. When the moon lies farthest from the earth is in its orbit at a distance of 4 lakhs 5,504 km, it is said to be an apogee position. Due to reduced attraction of the moon, the tide is also 20% less high. This is known as Apogean tide. This tide known as Apogean tide. Perigee. In its elliptical orbit, when the moon lies closest to the earth at a distance of 3,63,396 km, it is said to be in perigee position. The perigee position increases the attracting force of the moon and the tide is extraordinarily high. This is known the Parisian tide. The moon passes through its perigee and apogee about once in a month. What is tidal bore? A tidal bore is a high tidal wave near the mouth of a river or in a narrow estuary. It advances upstream like a wall of water about 5 to 8 meters. As for example, it is occur in the river Hooghly, Yangtze-Kiang, etc. Tidal bore occurs due to some factors. Number one, during high tides. Number two, if the river mouth is overslitted and become shallow. If the flow of water gets obstructed during high tide, the level of water may rise. If the river mouth is constricted inland and wide at the mouth during monsoon when a river is almost full. Now, effects of tides. The effects of tides are: number one, tides clear out the refuse materials and waste from the river mouth during ebb tide. Number two, tides make some of the river navigable. They help many big ships to reach the port located in the shallow water in the interior. Number three, tidal energy is harnessed by the power of high tide and low tide. Number four, sea fish enter river during high tide. Mixing of saline water takes place during high tide at the river mouth. These make river water unfit to watering crops. This is the disadvantage. Saline water at high latitude keep the port ice free. There is some another question arise. What is supermoon and micromoon? Sometimes full moon occurs close to the moon's perigee. Then the moon look larger than the normal full moon. Then it is known as supermoon. As for example, it occurred on Monday, 28th September 2015. If full moon occurs close to the moon's apogee, the moons may look smaller than the normal full moon. Then it is called the micromoon. It is occurred on the Thursday, 5th March 2015. Blue moon, it is occur in second full moon in a single calendar month. On Friday, 31st July 2015, the full blue moon is occur. So, we have finished our chapter Hydrosphere.